So let's get started. Let's first look at the interface between the microcontroller and the RA8889. Here is the interface definition. Define the P2 port as a communication interface. P2.7 is a selection of SPI films. P2.6 is the data reading port of SPI. P2.5 is the data write entry for SPI. P2.4 is the clock for SPI. P2.3 reset for RA8889. This example uses software to simulate SPI communication, and compatibility will be better. It's easier to debug. The SPI connection between the microcontroller and the RA8889 is shown on the right. Change PS to 20 to 101. This is the SPI for communication method. The actual connection is shown on the right. The actual number of wires is only a few. Does it seem simple? Let's start explaining the program code. The first is to initialize the I/O port of the single-chip microcomputer STC8H8K64U. And then the LEDs are blinking to indicate. Then send a reset signal to RA8889. Then initialize the RA8889. Next is the functional demo code. Includes display text introduction, geometric drawing demo, BMP image display, JPG image display, fade in and out demo, playback AVI videos, PNG image display. Altogether, these demo codes. The following is an explanation of the code of each demonstration function. Display character introduction. Do full screen fill color. Set font display parameters. Output string. Draw a few more rectangles to fill in the boxes. Do the full screen fill color. Draw a few more rectangles to fill in the boxes again. Finally, send the string display. Geometric drawing demo. Do the filling to clear the screen and then display the prompt string. Clear the screen. This is drawing a straight line. This is drawing a triangle. This is drawing circles and ellipses. You can also draw curved curves and filled arcs. It can be filled or not filled. Draw rectangles and optionally with rounded chamfers. The drawing function is implemented by hardware. Display speed is quite fast. It's unmatched by software. These functions can basically meet the design requirements of the UI interface. Show BMP picture demo. Images are pre-burned in Flash. Then use DMA to read and display. The front part is also filled with color, clear screen, and display strings. Next, initialize Flash. Then loop through to display 3 BMP pictures. Use this DMA function to display pictures. The function parameters include the address width of the picture and the coordinates to be displayed, etc. The microcontroller only needs to send these instructions to the RA8889. Show JPG image demo. Also clear the screen first and display the string. Next, initialize Flash. Note that the initialization here is different from calling BMP. Recycling shows 3 pictures. The function is the same. First send in the parameters, including the address size of the picture and the coordinates to be displayed, etc. Since the display speed of JPG is too fast, it needs to add some delay. Our RA8889 built-in JPG decoding. Hardware decoding shows JPG speed is super fast. This feature is also the greatest feature of RA8889. Fade in and fade out function demonstration. Flash do the initialization first. Bring up 2 more pictures and put them in the cache. Put the pictures at 0, 480 and 800, 480 respectively. Then it is displayed to the main screen by fading in and out. The last parameter of this function represents the alpha flux of the image. Increasing and decreasing the value can make the switching effect of fading in and fading out. Playback AVI video demo. RA8889 internal key hardware decoding AVI function. Use STC8H8K64U to easily play small videos. The microcontroller only needs to place a few simple instructions to the RA8889 to play the video. First, initialize flash. Then set the parameters, including the address size of the video and the coordinates to be displayed. Then execute the command to open the window and play the AVI video. Isn't that simple? Demo showing transparent PNG images. Initialize flash first. Then use the linear DMA function to read the PNG data and put it in the cache. To display PNG images, just call these three functions. We added some code to the program to make the PNG image move. The next step is to explain the operation. The video memory is planned as follows. The width of the layer is set to 1600 and the height is set to 480. Bring up the background image. Stores in these three locations. Coordinates 0, 0 for the main display, 0, 480 as a layer overlaying PNG, 800,480 backup as background cover. Through initialization and DMA functions. Put PNG data reads in the cache. Then restore the linear data of PNG to a transparent graph. Then copy the layer to the main display layer. Finally, copy and restore the backed up base map. And then you add the loop, and you get this dynamic effect. We just need to change the coordinates of the PNG image. The above is the code explanation. Thanks for watching.